What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do the last problem of AtCoder Beginner Contest 154, and then we'll just see what we'll try to upsolve more problems after that. And then I might actually create separate videos explaining all how to solve every single of these problems, because after we finish problem F, we would already know. I kind of know the gist how to solve every single of these problems, and I could create like tutorials for all of them and explanations. So yeah, that's what I'm gonna do. How you guys doing, by the way? If no one's in the video, no one's in the chat. That's okay. That's okay. It doesn't matter. Doesn't matter. All right. So let's just get into it. Let's get right into it. All right. So the final problem is many paths. So you are on a two-dimensional plane. One operation, you can move up one and to the right one in the positive y direction. Okay. So you can move up one, x, move up one to the right. Okay. So the function f of RC is the number of paths from 0, 0 to RC that you could trace by the following operation above. So now you're given integers R1, R2, C1, C2. Find the sum of f of ij over all the pairs of I and j such that R1 is less than or equal to I, R2 is less than or greater than equal to I, C1 is less than or equal to j, C2 is greater than or equal to less than j. Okay. And then after that, we just need to mod by 10 to the 9th plus 7. Okay, so let's try to do this. Okay, so the number of paths from starting point 0, 0 to RC. So I think I did a problem similar to this on Code Forces for the number of paths from 0, 0 to RC. I think what you could do is the number of paths, because if you're just going to go right and go up, the number of paths is just going to be R minus 0 times C minus 0, because that would be the number of paths it takes from 0, 0 to RC, right? Because you could only go up one and go right, and yeah, you can only go up one, or you go right, or you could go right, or you could go up and move right. So it would be R times C, I think. Okay. Now we need to sum up f of ij over all the pairs I and j such that this. So what I'm going to guess I'm going to do is I'm going to sum up all the values from ri, loop from ri up to r2, and then c1 to c2 for I and j from these values. And then I'm going to multiply the I times j, and I'm going to add it up. Okay, and then I'm going to take the sum of that, and I'm going to mod by 10 to the 9th plus 7. Okay, so let's just open Visual Studio real quick, and then let's solve this problem. So, whoa. So let's do this. Let's real quick. Okay, so what are the inputs? So the inputs is R1, C1, R2, C2. So I'm going to input those, and then we're going to do this mod 10 to the 9 plus 7. Okay. Okay, no one's in the chat, so that's all right. It's okay. If you want to type something in the chat, by the way, guys, if you just join in, you want to type something in the chat, say something in the chat. Yeah, I'll respond. Don't worry. Okay. Whoa, this is from the last stream. So I'll take these away. For the last stream, there might be a way to do the problem using dynamic programming, and I'll figure out a way how to do that. Okay, instead of brute forcing, because brute forcing and using prefix sum is not the most optimal solution for that one for last time. Okay, so first of all, I'm going to do read in R1, R2. I'll create variables for R1, R2, C1, C2. All right, and I'm going to read in R1, C1, R2, and then C2. Okay. So I read in R1, C1, R2, C2. Okay, now we need to take the sum of f of I and j and do that for all the values of between R1 to R2 and j R1 to j of C1 to C2. So we're gonna loop from the boundaries of R1 to R2, and then for j we're gonna loop from C1 to C2. Okay, and then we'll compute that. So we need to also mod by this number. So I'm gonna actually just create a n variable to mod it by. So let's just call it yeah, let's call it end. it's going to equal to 10 to the 9. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 zeros, but it's 10 to the 9th plus 7. So this last one, we're going to make it 7. Okay, so we're going to mod that by end, our answer by n in the end. Okay, so now we're going to start I from R1 to R2. So I'm going to for loop. I is going to start from R1, and then I is going to less than equal to R2, and then I plus plus. Okay, whoops. And then here I'm going to loop from J is going to equal to R C1, J is less than equal to C2, J plus plus. Okay, so now we have those. Let's just to find the number of paths. We're just going to multiply I times J. So I'm going to do I times J is the number of paths. So this is the num paths. Let's call it variable num paths is going to equal I times J. And then after that, we're just going to multiply it. We're going to add it to our answer. So we need to find the sum of all these pairs, and we're going to add it to an answer. So let's call an answer variable 0. And then we're just going to add answer plus equal num paths. Okay. So based on our, if you remember what, so because we need to avoid overflow, right? Because we need to mod it by 10 to the 9 plus 7. If the number gets too large, that's a bad idea. So what we're going to do is we're actually going to mod it by 10 to the 9 plus 7 every single time, and then add it, right? Because when you could distribute the mod whenever you add something. That's part of number theory properties. Like if I do like 5 mod 3, if I do like 5 mod 3 plus 4 mod 3, right? That's the same thing as 5 plus 4 and then mod 3. I hope that understands. If you guys understand that. But yeah, that's what it is. So yeah, we'll do that for this part. So we're going to yeah, we're gonna do that. So we're going to take num paths. Let's put parentheses, and then we're gonna mod it by end. Okay, and then after that, we'll just see out end answer. Okay, let's see if this works. If it doesn't work, I have another idea that we could possibly use. We probably could come up with a recurrence relation using dynamic programming. So let's just see. Okay, we got wrong answer. But is that the only wrong answer? Okay, no, we have more wrong answers. Let's look at detail. Let's wait until it's all done. Let's just wait. Okay. Okay, so we got all wrong answers. Okay, that's not good. Okay, let's go back to the tasks and just see what the test cases are. So if I put 1, 1, 2, 2, we should get 14. So let's try that. Okay, so we get 9. So let's go back and see why we do not get it right. Okay, so from 0, 0 to 1, 1, F is 2. Oh! Okay, so we can't actually multiply R times C. I thought you could, though. Let's see. F is 2. You add 1. R minus 0. So 1 times 1 plus 1. Maybe we have to add 1 to it. I'm pretty sure that's how you count the number of paths, though. Oh, okay. So we got 13. We're close. Let's just see. So we got plus 1. Maybe we have to add 1 more to the answer again. The final answer. Maybe we have to do that, plus 1. to get it to 14. So, okay, yeah, it's 14. Let's try the other ones. Okay, that's definitely not right. 602999224. That's not right. Let's keep thinking. Up 1 to the right. Right, up, right, up. I'm pretty sure you could just multiply them. R1 minus R2. Must be a way to solve this. There's definitely a way to solve this, but I'm not receiving enough video to maintain smooth screening. Damn, how am I not experience? What's the problem? Okay, they're saying I'm not experiencing enough smooth screening, but is what it is. Sorry guys. Let's see. There must be a way to solve this. So from 1 to 1 we get 2. 1 to 2 you're supposed to get 3. So we need to find a math equation to get this. Number of paths, okay. Number of ways of paths to go from one chess piece to another. Move 1 right. 17, choose 4, 14, choose 7. Maybe we could use combinatorics. Might be able to solve this using combinatorics. So number of passages for rook. X squared plus y squared, the number of system of equations. Okay, that's not a good idea. Okay. To go right and then up. Let's see. So you go right 1 and then 2. Subtract, maybe if you subtract 1 minus, okay, so I want to get the number of paths from 0, 0 to 1, 1. If I can't just subtract 1 minus 0 times 1 minus 0, I cannot do that. Because f of 1, 1 is actually 2. What if I do 2, 1 minus 0 plus 1, 1 minus 0, then plus 1, and then multiply it by the answer. So what if I do I plus 1 times j? So let's try that. $16. Okay, hold up. And what if I subtract 1? That'll be, I think that would make more sense. Let's see. Okay, so that'll get us 14. Okay, let's try this one. I don't know why the answer is super duper large. Yeah, why is it super duper large? 5555944. Okay, let's see, let's keep thinking. It's good to think. Think. It is a good idea to always think. Maybe we're overcounting some paths. That's probably what we're doing. Let's just keep thinking. If we still can't, okay, I'll put a timer. And if we can't figure out the problem in 20 minutes, I'll look at the editorial. All right. So if I put 20 minutes, can't figure out the problem, we'll usually look at the editorial. Let's see. 2, 1, 2. 1, 2, 3, 2, 1, 3. 2, 2 is 6. F of 2, 2. So 2 minus... What if I do 2 minus 0 plus 1 times 2 minus 0 plus 1? No, but that's... I'll give you 9. 2 minus 1 plus... I don't think we can brute force go through every single possible outcome from the beginning to the end and count the number of paths. But I don't want to do that. I don't want to go up, right, up, right, up, right using the DFS because that's too much. It's way too much. That would be like a n cubed because you would have to use DFS on here and then do this for that many number of times. I plus 1 times this value. Must be a way to solve this. We're going to solve this problem. I have a feeling we will solve this. If not, we have to try something. We have to try something. Okay, guys? We have to try something to solve this problem. Wait, let me see. What is the time in India, by the way, right now? Time now to India. What time now is in India? Oh, it's 9 a.m. Okay, maybe that's the reason why everyone's asleep. By the way, put down in the chat. Keep it up. Thanks, man. Thanks, man. Really appreciate it. I'm going to try to keep it up. All right. Okay, so we're still back at this trying to figure out the number of paths it takes from going to the going up one and right one, right? The number of paths that it takes to go to the right one and go up one. For the function RC, the number of paths go from 0, 0 to RC. So that's what I'm trying to figure out right now. So any of you guys in the chat, if you just joined the chat, this is just the problem we're going over right now, the last problem of beginner contest 154. So basically we're just trying to figure out the number of paths it takes from going from 0, 0 to R, from point 0, 0 to point RC, just from going up one and to the right one, right? We're trying to figure out that. And then after that, we're trying to sum up all of those from R1 to R2 and C1 to C2. So that's what we're trying to go over. So right now I'm trying to figure out how to actually get the path, the current path, to count the number of paths. So yeah, that's the issue right now. So let's see. I'm not good at combinatorics, so I'm trying to figure that out. But yeah, if you guys have any hints, you could say it, message it in the chat, and I'll answer it. I'll try it. I mean, okay. So let's go back to this. 0, 0 to 1, 1. Okay, so 0, 0 to 1, 1 gives us 2. The reason, because you could go up 1 and then go to the right 1, or you could go to the right 1 and then go up 1. So x minus 0. So I thought that it's just x minus 0 times y minus 0 and then plus 1. Apparently that's not right. Maybe there's something wrong with this. Okay, hold up. Let's go over this again. I minus j. Okay, I times j is, so we're looping from here to here. Okay. Let's see. So I minus 0 times j minus 0 plus 1. So this is, originally I thought it's like this, but this is not right. Oh, maybe I have to mod it by n again. Might be the case. Maybe that's the problem. It just didn't copy. No, it's still not right. We're getting closer though. It's not as large as before. Okay. Let's look at 14. Let's look at the first test case. At 13 plus. Add 1. Let's see how we would do this. Add 1. Yeah, so that is right. 14 is right. But the second test case doesn't work. So let's just try to figure out why. So if I take, so it gives us 568,244,000. The real answer is 602 million. So we are off by 3 million. No, not 3 million. 14 million, about 14 million, I think. So we have to try to figure out why we're off. There might be some paths we're not including. So let's see, think about it. Because ideally this does work. Should work. Are we going overflow? I don't think we're not going overflow. Because our first point is 314, 159. So when you multiply them, you shouldn't be going overflow. If it went overflow, it would give us some strange negative number. IJ, so you compute this value mod, 10 to the 9 plus 7. Move right 1, up 1, right 1, up 1. Let's see. We gotta figure this out. Let's try to figure this out. Okay, let's see. 501. Try to figure this out. I might switch up my live stream to a different time. Instead of 12 a.m., maybe I'll live stream at a different time. So maybe I'll live stream at what is a good time? So I think 9 a.m. Eastern to India time. Let's see, what is that? 6:30 p.m. Okay, so I might actually live stream tomorrow at 9 a.m. So I might actually, which is 6:30 in India. So yeah, I'm gonna start doing that. I'll probably put a post on the community chat for that. So yeah, back to this question. We need to figure out why our problem is not right. So if I have 2, 1, it should give us 3. 2 minus 2 times 0 minus 2, 3 plus 1. 3, yes, that's right. 4 plus 1. Oh, wait. No, that doesn't work. Two doesn't work. Some would not be right. F of 2. That would give us 6. Because if our function is 2, this says it's 6. Well, in reality, ours would give us 5. Let's see if we plus x. Actually, what if we try plus I? But that's just the same thing as I plus 1 times j. Well, yeah, that is the same thing as I plus 1 times j. No. So we are off by... We are off by... So let's do -1, answer -1. Let's try this. Okay, so yeah, that's 14, but let's try this. Check out this one. Still off. Oh, 634048222. Okay, so I think we're getting close. So now we're over counting. Okay, so originally we were under counting. Now we're over counting. Let's see if we pass any tests. So I know we failed the first two, the second one, but let's see if we pass any more. Okay. Huh, okay. So we got 3 of them are wrong. 4 are wrong. 5 are wrong. 6, 8. Don't tell me 10. Give me at least 1 right. Come on, man. Okay, so okay, the first test is right. That's good. Everything else is wrong. Sample max score. Okay, let's see. We are moving n-1 steps in the upward direction, n-1, n in the right direction. Oh, okay. N plus n minus 2 factorial over n minus 1 factorial times n minus 1 factorial. M plus n minus 2 factorial over n. How did you get that equation, though? So are you doing n plus n choose n... Or you do n minus 1 choose m minus 1? Is that what you're doing? M minus 2 choose. So if we do, let's see. Because if we do, wait, okay. So if we, okay, let's look at the combinatorics formula. Because if we do, let's see, n minus 1 choose k, wait, hold up. Hi, how you doing? If you're new to the chat, right now we're just doing this problem of many paths. So basically, we're just we're trying to figure out the number of different ways you can move in one operation. You could move from point 0 to point RC. So the number of different paths you could go, and the paths you could only go are up 1 and then to the right 1. So that's what we're trying to do in this problem right now. So yeah, one of the guys in the chat said that it's m minus n plus 1 c, right? N plus n minus 2 c n minus 1. That is... Why minus 2? Because there's m minus 1. So m minus 1 is in the upward direction. M minus 2 is in the right direction. So if you choose m plus n minus 2c n minus 1. Minus 2. You know, that sounds right, but I'm not really so sure how you got that answer, though. Because if you're going, let's see, if you're going right 1, if you're going from 0, 0 to RC. How many paths can you go from 0, 0 to RC? You could go n minus 2 plus 1 times... Why is it minus 2? Because if you're choosing... Is it because of the going right all the way in one direction instead of going up? Because that one, not so sure. Because if you're going right, let's say you keep going right. I gotta draw this out. Hold up. Excuse me for a moment. I think I'm gonna actually go look at the editorial soon. Because combinatorics is not my forte. Yes, I think you probably can do this using DP. If you could figure out the formula to get from 0, 0 to RC and figure out that recurrence formula, you could probably memorize the solution from R1, from the range of R1 to R2 and C1 to C2 for every I and J, for all the pairs, right? Then you could use like the previous stage of going up one to the right to figure it out. But yeah, there might be a way to do that. The thing is, I don't even know. I can't even figure out this formula. So n plus 2, n plus n minus 2, c n minus 1. Okay, I'll try that. I could actually try that using that formula. Some of the guys in the chat said, so he said I plus n plus, let's see, we'll use this. We'll use this formula. So if we're going to use n plus n minus 2, c m minus 1, that'll be n plus n, that'll be I plus j minus 2, c I minus 1. So it would be I plus j minus 2, and then c I minus 1. So if we're going to do that, we need to figure out a combinatorics calculator. So let's try to do that. There's should be a fast way to do this. Okay, yeah. So you could do. So let's copy this solution, NCR, and do a factorial of this. So we'll do these. Take both of these actually. So we're gonna take both of these, and let's make these long to make the range larger. Yeah. Let's make this long. Okay, and then we'll do NCR this, NCR. Okay. So we'll try this, and then let's see if this works. So going back to here, how many paths? Let's try this. GFG. Huh. All right, thanks. What is GFG? Oh. GFG. I typed in the wrong one. DP path from one to another. Ooh, Geeks for Geeks. Oh, okay. Huh. Wait, okay, so this is like depth first search. I don't want to do this way. because this is going to take, you're going to have to go through every single path. And that's not something I want to do. Geeks for Geeks, number of paths. Let's see, number of paths. Oh no, not this, not case order. I don't want to count the number of walks. That's not what I want. Geeks for Geeks, number of paths. Number of paths from one to another. Oh, okay, yeah. What is he doing? Huh. It's a DP question. Bottom up using recursive cell. This is insane. Ah, okay. This is where you come from. Okay, n plus n over minus 2. How did he get this, though? Where did this equation come from? Pulled from thin air. Oh, I just accidentally click on PHP. Okay, let's try this. Wait, what's the problem? Wait, why can't? What's the build error? Fact is not found. Okay, let's take this. Whoops. Division by 0. What am I getting division by 0? It's cool that you can look at the assembly. Whoa, look at all this assembly. Anyway. How is it there division by 0? How am I dividing by 0? N plus n. I plus j minus 2. C I minus 1. Let's look at this problem again. Thanks for the suggestion of Geeks for Geeks, by the way. I wouldn't have thought about it. M plus j, n minus 1. Choose C n minus 1. M plus n, I plus j minus 2, C n minus 1. Oh, j minus 1. Whoops. It's j minus 1, not I minus 1. My fault. Still division by 0. That's really crazy. Okay. Let's try debugging. Okay, actually, let's look at the first test case. I think it's time to look at the editorial because I've tried. It's been 20 minutes. I think I'm going to look at the editorial. Ah, so, okay, if we're getting it wrong. I tried I plus j minus 2. Why are we still getting it wrong? We're still getting it wrong. Cn minus j minus 2. Okay, let's go look at the editorial. And then try to implement it. Most of AtCoder's editorial are pretty useless anyway, because they don't give us any hints at all. So let's look at this. Let g of RC be the sum of f of I. Go to RC. Okay. Desired answer is g of R2 C1 minus G of R2. C1 Ci minus 1 G of R2. What? Where did this come from? G of RC. Can we hold the f of R plus 1? Okay. Yes, I guess this is right. Every path it is such a path from 0, 0, I'll move. Okay. Whether the number of paths. The number of paths such as 0, 0 of the Ri and moves. Is equal to R plus 1. Also holds that f of RC is equal to R plus C choose C, which is equal to R plus C factorial over R factorial C factorial. The sum of fy's whose number of values is O of n, so it's enough that what? I don't understand. They lost me here. Move right to the R plus 1. You could move right to what the heck are they talking about? What are they talking about? By the way, the number passed from 0 to 0 is f of c1. Okay, let's keep trying. Let's keep trying. R plus C choose C. So they said it's R plus C choose C. Let's try that actually. I think the one on Geeks for Geeks is right, but then we're off by a factor. So yeah, there must be some weird issue with that. Yeah, so there's probably some weird answer for that. Let's try. It said R plus C, so it's I, which is our I plus J. Choose C, so we'll do our choose C. C is our J, so we'll do that. Let's see if that works. Okay, that works. Okay, that works. 14 works. Okay, let's try another one. Division by 0. What is the problem with division by 0? Something is up with this division by 0. Let's go debugging. We're going true debug mode right here. Okay. Oh my gosh, I have to change these all to longs. Because it probably overflows. That's probably what happened. Okay, it still didn't overflow. Let's keep seeing. Does it ever go to 0? It goes to negative. Okay, so it does overflow. I don't think can mod distribute over an overflow? So yeah, so because it overflowed for factorial, it goes back to 0. So we need to find a way to do factorial without overflowing. Oh boy, that's the problem. Okay, Let's see how to do factorial without overflowing. Paths. Question is similar to 62 unique paths. Maybe you are right, but I don't know what that is. Let's see, 62 unique paths. Ah, I have not done this leak code question. Yep, it's probably very similar. If it's on leak code, it might actually be an. If it's on leak code, it might actually be an interview question. So, okay. Anyway, back to our issue. We are getting overflow. We're getting overflow because we are going to. Long is not big enough for this problem. So let's see. Can we mod by the n factor? So then, let's see. Does mod properties work for multiplication? Let's see. Let's see. I'm not so sure if I remember. Okay, so yeah, that's right. Does it work for multiplication? So I know it works for addition. So it is compatible with multiplication. Okay, so if it's compatible with multiplication, we can mod by the large factor. So whenever because this is our end result that we have to mod by. So we can mod by this end result. So we can multiply and then mod by it. So then we could try to avoid overflow. Because we're going to mod by this end result anyway. Why can't I mod by this end result? And it's right here. What? Is my compiler on drugs? It's right here. How? It's literally right here. Okay, wait, okay. What? Is something wrong? Why can't I do this? Something's wrong with my... Something's definitely wrong with my compiler. Okay, yeah, so that was weird. That was a weird issue with my compiler. Okay, let's see if we overflow again. Ideally, we won't, because we're modding. So once it reaches an end result. So technically, we're not actually calculating factorial. We're actually modding by it. Mod factor. Okay, so I don't think I'm overflowing at all. Okay, so yeah, okay, I don't think I'm overflowing at all. So now I'm actually going to try test it out. Okay, we're probably gonna get TLE the way it sits here. Let's check out this. So why are we getting TLE? Oh, what the? Okay, so that's right. We're getting TLE. We are getting TLE. Why are we getting TLE? Let's see. Oh, it's recursive. Oh my gosh. Okay. We are calculating factorial over and over and over again. Oh, that's a problem. Okay. Okay, what if we pre-compute all the factorials and then do it? So, hold up. So let's look at the constraints. So, okay, so our factorial goes up to 10 to the 6th. So what if we pre-compute to, what is a max factorial you could pre-compute up to? Can you pre-compute factorials up to 10 to the 6th? I'm going to try something, okay? Let's go back to this. Factorial, let's see if we could pre-compute the value. So let's see how long it takes for factorial if I run it 10 to the 6. So like let's from here, let's comment out every okay, how about let's not comment out everything yet. Right here I'm gonna print out 10 to the 6. So 1, 2, 3, 4, 5, 6. And print out this. Let's see how long it takes. Because if it doesn't take that long, then we could pre-compute all the factorials and store it into an array of values of 10 to the 6. Okay, so I got 0. Why is that? Why am I getting 0? That doesn't make any sense. Hold up. Goes to negative. Okay. Oh my gosh. How to deal with overflow and factorials. We have to deal with that. Okay, let's see. How to deal with overflow. Tuesday doesn't give you a limit of sign integer. Sign integer limit is actually 2 to 2 million. Oh, 21 million. You'll need a C++ number library. Oh my gosh. Okay, I don't want to do this. I'm not downloading a number library. Let's see. There must be a way to calculate factorial without overflows. If not, I'll just look at calculate. How to C++ calculate factorial for large numbers. Okay, let's see. Okay, we have to create an array of results of max size the number of digits in the output. When we need to store the value result as 1, and then result size as 1. Do the following from 2 to the n. Multiply x with the result, then update result and result size to store the multiplication result. This initializes the carry for 1, then multiply the carry. Let the carry be the bound. Store the last digit of the product, update the carry. Okay, wow. That is intense. That's pretty intense. Okay, we're going to have to do this. Okay, we'll do that. Okay, so number of digits is max multiply. Let's see. What do you multiply? What if we just copy this? Probably could. Let's just copy this. It's okay to copy code if you later understand somewhat of it. Okay, this is gonna give me a weird issue because of result parameter, I think. My factorial is not factorial. Well, this is a hard problem, not gonna lie. Gotta deal with overflows, gotta deal with... Alright, let's see how long it takes for their factorial to work. Runtime error, stack round variable res was, what was it, corrupted. Oh, max digits 500. Because it's... let's try... Let's try this size. Still corrupted. Okay, okay. Okay, I'm going to try to code this up myself. Okay, so they're saying the stack of result is corrupted because I'm guessing the number is too large. So that's why the stack gets corrupted. Okay, so okay, so I'm going to actually not do this. So what I'm going to do is I'm going to create a vector int for the result. So let's kind of do the same thing here. We don't need result size because result size is just results dot size. Let's get this now. So this we don't need. Okay, so now we're gonna have this issue. So what we're gonna do is we're gonna do int result size is gonna equal to result dot size. This is result. This is result. This is gonna be result also. So store mod by 10, then divide by 10 to carry. Okay, so this is some basic elementary mathematics, I guess. Here we don't need this. We don't need result size. So we just created result size, multiply it. Yeah. We don't need this. This is result. Yeah, this is result. This is going to be max size of max. Let's do +1. So 500 digits. Let's see if this works. Debug fail subscript out of range. Okay, hold up. So maybe instead of 500, let's give it... Wait, how is a subscript out of range? This factorial can't... Is this over 500 digits? Okay, well, hold up. Let's try 100. See if this code works. Okay, well, I'm getting a weird number. 936 whatever something. Not sure if that's right. Hold up. Did they get it? Now let's run their code. See their output. Okay, so they do get a number, but Yeah, I think they get the same number as us. 933262143. Okay, yeah. So they do get the same number as us. Starting value would, you have to loop through all the zeros until you get the first starting value then. Okay. Okay, so we're gonna actually do this form of getting factorial. So that gets that. It does that. The issue with this is that if you're gonna do it this way, we need to think about how many digits. Because if you get the factorial of a very large number, and then we have to store the factorial also, right? Unless we calculate for every single value, but that's not a good idea. Yeah, also, how are we going to divide the factorials? Factorial n over factorial r times factorial n minus r. Yeah, this is pretty hard. Let's see. How are you guys doing in the chat, by the way? I'm thinking about just looking at the solution, someone else's solution at this point. I've exhausted a lot of effort on trying to do this. Exhausted too much effort. This is just because after we get the factorial, we still have to multiply it. So unless there's a way to multiply. Oh, okay, we could do. Okay, hold up. Okay, then we could do. Oh, but how you divide? That's a big problem. How would you divide it? Result, because you could do result times. How would you divide? How would you divide? Oh, this is a tough question. Yeah, I know it's similar to LeetCode's 62 unique paths, but LeetCode doesn't deal with overflow though. So, like, you're not gonna be asked an interview question where you have to deal with 10 to the 6, right? Where your factorial goes over negative, goes to negative, and then goes to 0. You know what I mean? I don't know. This is tricky. This is a very tricky question. This is a very, very, very tricky question. I'm gonna end the stream in 15 minutes, so I'm actually going to look at other people's results because I am stumped. Let's see how they did it. Okay, let's see how they did it. What the? Wait. Euler fee. Wait. Hold up. You read them the values. Okay, so they're doing what I did. 0 to C+1 CMB. Okay, so this is what we're trying to do right here. But how do you calculate this though? CMDB. CMB. Why is some of this in Japanese? CMB. These guys already have presets defined. You know, maybe we should, like, whenever you do competitive programming, maybe you should try to just write a bunch of presets to deal with the overflow and all this other nonsense, and then just, once you deal with it, you can just use it anytime you want. You know what I mean? Make your own libraries dealing with overflow, so you don't have to deal with it during the contest. Okay, so they have POW, they have this. Where's CMB though? Where does he define CMB? Okay, so he even has AB cosine theta. Mod int. Okay, CMB. Man, my gosh, this guy's so prepared. Right here. No. Wait. Wow. Nope. There must be a way. Euler's phi. So where did he get this? Is there a way that I could, like, control C on his thing? Okay, hold up. I'm gonna try to find other solutions. More Japanese. Okay, so I think this makes more sense. Okay, add the combinations of C1 plus C1 to C1. Okay, yeah. Then add the combinations at mod by M. Okay. Okay, so how do you do combinations? He had a factorial inverse of K. This is beyond my understanding of math at this point. Beyond my understanding. Factorial inverse. I don't never heard of this before. What is a factorial inverse? What? What is going on? Factorial inverse. Okay. Let's actually try to code a solution. Let's actually code a solution. Like, let's copy word for word and try to understand what he's doing. Because I don't understand factorial inverse. But this does make sense, though. So in the editorial, remember, they said that you could loop from R plus 1 to C, right? If the function R plus 1 C, which is the number of paths from 0, 0 to R plus 1 C, is actually equal to f of R0 plus f of 1 up to f of RC. So that is the reason why he does this. He's summing up the values from R plus 1 to R plus 2, and then he does the combinations of that. Then he does the combinations of C, right? C and then C1, C2. So that's what he does here, summing up the combinations. So that I understand, but creating the combinations is kind of the thing I don't understand. So this part I don't understand at all. So anyone in the chat, if you understand, yeah, you got a lot of classes. It's okay. It's okay. Love to stay, but you got classes. I know everyone has classes. It's all right. By the way, do you guys, any of you guys here understand factorial inverse? Because I don't understand that. I'll put this question in the chat. Any of you guys understand factorial inverses? Because I don't understand that. That is beyond my understanding of number theory. Factorial inverse. What is going on? This doesn't make any sense. Inverse of factorial is the inverse of the factorial function. So 1 factorial is 1. Factorial inverse of 1 is 1. 2 is 2. So on and so forth. You'll notice there's no number such that n factorial is equal to 3. So factorial inverse of 3 is undefined. No, there is no simple formula. That's why online calculator gave you a function in that form. What is this? What is this? What's NV1? I don't understand. V times m factorial. Is this a multiply? These brackets? These brackets? Gamma function does not have an inverse. We restrict the factorial function for trigonometry. This find a function where he is. Letting ln is L squared and my gamma approximation. Okay, so he's using some gamma approximations. I don't want to do that. But I didn't know there's such thing as inverse factorials. Now I'm on Reddit. I'm going all over the place. Okay, we'll just take we'll just take his code and read it. Okay, so let's take this maximum 2 million. Okay, so well, let's do that. Okay, so let's take this out, and we're gonna use his code of factorial inverses, and then we'll be on our way. Okay, so he has this. I think max is the number of digits. He has this. Let's create vector long factorial, and this is going to be max. Why can't you do this? What? It's right here. My gosh. That doesn't make any sense. It's literally right there. Okay, let's create this called factorial inverse. And let's create inverse. We're going to create 3 arrays. Let's get rid of this. It's literally right here. Oh my gosh. Oh my gosh. My gosh. Okay, whatever. All right, let's use this function to calculate factorial inverse. Let's actually code it up so we actually remember how they did this. So, Japanese people, you are genius. You are very, very smart. Okay, so factorial 0 is going to equal factorial of 1, which equals to 1. Okay. Factorial inverse 0 is going to equal the factorial inverse of 1, which is equal to 1. Okay. Inverse of 1 is going to equal to 1. Let's loop from 2, go up to the max number of digits and add. And we're going to take the factorial of I times factorial of I minus 1. Whoa. Okay, We'll take factorial I, this is factorial I minus 1, multiply by I, and then mod by mod. Mod is going to be this constant E, okay? So we'll take this and then, oh, okay. Okay, that makes sense. This I don't understand. I do not understand this. I'm gonna have to ask on code forces because I don't understand what they would mean here. So mod minus the inverse of mod I multiply by mod over I mod by mod. The inverse of a factorial is equal to mod minus the inverse of mod I times mod over I mod by mod. Factorial inverse is equal to factorial inverse of I minus 1 multiplied by inverse of I. So I don't understand this equation at all, but I'm going to ask on code forces. So I don't understand this equation and I don't understand this equation. There might be like a research paper that someone wrote. It might help, but I don't think I don't have time to do that. So, okay, now let's look at the combinations. Function that calculates combinations. So they use this, which is some voodoo magic that I don't understand. If n is less than k, we return 0. I think I understand that part. If n is less than 0 or k is less than 0, return 0. Okay, that I understand. Because this I don't understand. Factorial of factorial inverse of k multiplied by factorial inverse of n minus k. Mod by mod. Mod by mod. Don't understand this. I don't understand this. And this, what does this even mean? Let's actually look at the translation of this Japanese. Maybe this is like, maybe this might be, this actually might be, this doesn't tell me anything. Let's translate it to English. Fact is attached property. Is this some nonsense or something? It's probably some. It's not nonsense. It might be some hint. Let's paste the whole thing. Okay, let's paste the rest of this. Let's see. What does this mean? Fact is attached property. Fact is an attached property. It's just doing this that many times. Okay. Well, whoever you are, I wish I understood Japanese. It might be a subtle hint or something. A hint. I don't know. Okay, so now that we did the voodoo magic of factorial inverses, did that magic of voodoo nonsense, let's actually calculate it. So let's do answer plus equal to the combination of R1 plus RC1 R1. Okay, this one I understand because they showed it in the editorial. Answer plus equal combinations of C2 plus I of I. And then we mod by mod. So we're going to go from C1 plus 1 and then go to C2. And we do a combination of R2 and I. Answer mod equal to mod. Okay, then we're gonna just see out answer. This is one hell of a way to do. I'm gonna post a question on Code Forces to see if anyone understood this, because I, for one, don't understand factorial inverses. That guy's just blue. I don't know how you did it. Okay, I'm getting 0. Something's wrong with the code. What is wrong with the code? How? How is the code wrong? Maybe I have to do +1. I'm getting a weird answer. Okay, let's just try to figure out what we did wrong here. What did we type wrong? We sure as hell don't think we screwed anything up. Parentheses. Pretty sure we didn't screw that much. Didn't screw anything up. K n minus k mod n. Oh my gosh. Oh my gosh. And fin I minus 1 times inverse of I mod n. Inverse mod n. I don't understand this code. This part I don't understand. Let's debug. Let's debug. Combination of R1 plus 0 and R1. R2 plus I, R2 plus I. C2 plus I, R2 plus I. C2 plus I, R2 plus I. C1 plus 1. C2, R1 plus 1. Oh, I didn't call fact. That's why. Okay. Whoops. Okay, I'm gonna read up about that later, how this equation actually works. But yeah, for now, I'll just submit it and get AC, and then be on our way. And I gotta end this. Gotta end this live stream. Must be some. It might be a tutorial on factorial inverses. Yep, okay, that works. This is a hard problem. I don't know what's on a beginner contest. Okay, yeah, so that works also. Okay, I'm gonna post a question on tutorial on factorial inverses, and we'll be on our way. Alright, I got AC'd. Alright, I hope you guys enjoy this live stream. Rate, comment, subscribe. I'll check you guys later. I'm gonna change my live stream from like another time. So like probably gonna live stream from 9 o'clock from now on. 9 o'clock Eastern, which in India would probably be 6:30, I think. But yeah. So yeah, rate, comment, subscribe. I hope you guys enjoy this live stream. I'll check you guys later. Peace.